This is one of our lunch and learn sessions, and for those of you who have not attended, our lunch and learns are maybe a little bit more frank discussion about the software, its capabilities, how to use it. Maybe digs a little deeper than maybe you'll see in other sessions like training sessions and so on. And in this coming year, we're going to spend a lot of time helping you, our customer base, understand and dig a little deeper into the simulation product line. And this is kind of the first installment. There's going to be some real basic stuff in here up to some, maybe hopefully pick up some tips and tricks on how we might use simulation. But I wanted to kind of give the opportunity for folks that maybe aren't comfortable with the simulation product to start to learn and pick up on the nuances of the product itself. To start out, let me just get an idea of who has attended Lunch and Learns. Now, this is a poll from GoToWebinar. What you'll see is you'll have an option to vote, just so I can get a sense of how many attendees have attended before on these Lunch and Learns. Give a few more seconds to vote here. And I could go ahead and close and share the results here. So most of you have attended our Lunch and Learns. So you got kind of an idea of what we do on these Lunch and Learns. So we'll follow that structure. For those of you who have never attended, welcome. I hope you attend many more. This is our way of discussing technical things with you without having the sales push to it. It's more of a conversational piece. I try to dig in as much as we can on a particular topic and introduce as much as we possibly can. So a couple other questions related to today's topic. The topic is very focused today, dealing with linear static analysis in SOLIDWORKS Premium. With SOLIDWORKS Premium, you do get simulation, and understanding how you are using simulation, or if you have the need for simulation, and where that might fit into your process now. That's kind of what my focus is today, is to go through some of the technical reasons why you would want this type of tool, and give you an understanding how to use it. So if you did happen to get it or have access to a seat, you can feel comfortable getting right in and using the software. Now, let's start out, for those of you who have dabbled with simulation. How many of you have used Simulation Express? Simulation Express is part of every seat of SOLIDWORKS. You can get access to it from the Tools pull-down menu, and I will definitely take a chance today and show you a little bit about its capabilities. Now, just to show everyone just kind of our cross-section that we have on. Some of you have not. Some of you about 50-50 here as far as using Simulation Express. Now, those who have simulation or have touched simulation, I want to just get a sense of why you folks might not use the full simulation product. Okay, Simulation Express comes with every seat, but simulation as part of SOLIDWORKS Premium. So if you don't do simulation, why? Why do you think that is? And there could be many reasons. I just kind of picked a few here. I'm hoping there isn't too many there at the bottom, but we can talk about where it fits here in a moment. Get a few more votes in here. All right, so let me go ahead and share with you the results on this one. So as I expected, I think there's this sense with simulation that it's hard to use, it's not easy to work with on a daily basis. And I've been working in this industry for quite a while, and I would say 10 years ago it was different. I can remember specifically going into organizations and meeting with their analysis group, a group of individuals that did it all the time. And as a designer or engineer, you develop the problem and you send it to that group. And that's definitely not the case anymore. So my hope today is we're going to get more comfortable with what you have. What is linear static analysis? What is the piece that's included in SOLIDWORKS Premium? If you don't have access to it, first of all, I'm going to show you what it looks like if you did, but we're also going to talk a little bit about Simulation Express and how you might get started. And then when you finally feel that you can bring that into your process, how you can go forward with it. Now, for the select few that said they don't need it, I hope today that maybe we can open your eyes as to how you can use the software to make it useful in your everyday work. I'm talking just making decisions on, how big a fillet needs to be, how thick a wall needs to be, material decisions, using it for the day-to-day design responsibilities, not necessarily, getting to the end result and saying, is this thing going to work? Making you a better designer by putting this type of analysis right up front. A couple other questions I have here. For those of you who are not using simulation at all, or you are, how many prototypes do you create on new products? As you start to develop and modify, maybe in the R&D phase, and you develop something new, do you prototype it? How many prototypes do you create? Now, this question is very important because analysis, some people believe that analysis is the be-all, end-all, and that's absolutely not what I'm suggesting here. Analysis is meant to be injected in the process to minimize the amount of prototypes that you'll create. Now, I'm going to go ahead and share this poll. I think it's very interesting. And what I want you to think about is the costs related to each prototype. What if you could cut down one or two of these prototypes just by making a better decision in the design process to get closer to where you think your final result's going to be? And that's realistically how a design engineer should be using the analysis tools inside of SOLIDWORKS. You can see some of you folks are creating 5+ prototypes, and if you put costs to that, I don't know what products we're talking about, but I'm sure they could add up very, very quickly in this process. All right, I think that we can go ahead and get started here on my presentation. So my agenda today, what I want to cover, some of this is going to kind of start from the beginning for the folks that don't have access to simulation, or those who aren't comfortable with it. This is kind of for you. If you're comfortable with simulation, hopefully you'll pick up a few things today. But we're going to go through the interface of simulation, how it fits into SOLIDWORKS. We're going to talk about its ability to be customized. We focus a lot on what we can do in SOLIDWORKS to make it fast and easy to use, but how can I extend that to the simulation tool? I want to go in detail about problem setup. When I say problem setup, setting your analysis specifically, how to navigate the tree. I'm not going to focus on any particular problem, but more where to go to find what, just so you're comfortable where those things are. And we can't really have this conversation without understanding what it means to be a linear static analysis. Now, we're focusing today on what's included in SOLIDWORKS Premium. And with SOLIDWORKS Premium, it supports linear static analysis for parts and assemblies. Now, to help make you comfortable with what's there, let's talk about what is linear static. And then I want to give you some help in some resources and places to go to get information. We'll go through some of the solving of a problem and viewing results and some of the things that we can do that are kind of neat with that. And then I want to close with maybe an introduction to Simulation Express, so that those who do not have the SOLIDWORKS Premium product have something to start with and get their feet wet with the simulation tool. Now, I talked about our focus today being on what's included in SOLIDWORKS Premium, and I just bring this slide up to kind of set the stage for what we're discussing. SOLIDWORKS Premium is the first level that includes some sort of analysis tool. And with this, the linear static for parts and assemblies, as you move up into the simulation bundles, you get other things, but I want to focus today on linear static with SOLIDWORKS Premium. So let's talk about interface customization and problem setup. So first thing in SOLIDWORKS, to get to the simulation tools, it's just like any other tool. I can go to the tools add-ins, and I'm looking for SOLIDWORKS simulation. Now, just to reiterate what these boxes do in the add-ins, the box to the left of the simulation, this will turn on the add-in for this session of SOLIDWORKS. If you go all the way to the right and check this box, notice it's under the startup column. This will start up simulation every time you start SOLIDWORKS, so it will be remembered as one of those add-ins that you're going to use. Now, I tend not to turn on simulation through tools add-ins because on our command manager there's a tab titled Office Products, and if I go to that, you'll notice that some of the tools that we use on a pretty regular basis are listed there as an icon. Well, SOLIDWORKS simulation can be turned on using this button here as well. So if I select it on, you'll notice it stays depressed, and it actually creates another tab on my command manager for simulation. You'll notice that that tab initially will have very little information on it, very little commands. There's actually a consolidated menu with two options available to me. You'll also notice that there's now a pull-down menu for simulation that allows me to get to a lot of these options directly from the pull-down menu. Other than those two things, there's very little that shows you in the interface that simulation is turned on. So some of the times you get confused that it's even on or not, or someone will complain that you have the license. But as long as that button is pushed in, you will have access to it. Now, I'm going to point out a couple other things that you'll notice that also helps me to understand that simulation is turned on. First of all, and I don't think, okay, a few of these aren't going to show up until I actually start and create a study. Now, I went over here to the design library because I was expecting to see something from simulation, but that will show up here in just a moment. And then also from my pull-down menu under the view menu in the interface, something should show up there. Now, I will take you back here because they do show up, but it doesn't happen until I physically create a study. Now, I'm going to just do that real quick. We'll talk about more detail into how to make that happen. But I wanted to just show you, and my simulation library is not showing up. This one absolutely should. Okay, so in the pull-down menu, you notice the view, we now have view simulation symbols. You'll notice that some of the commands have also been unlocked. So very subtle things within the interface to let you know that simulation is kind of working in there. Other things that you can do as far as interface and customization. First of all, our S key on our keyboard. Hopefully everyone has gotten accustomed to using the S key. If you're not aware of it, it pops up whether you're in parts, assemblies, drawings, or sketching environment. But if you right-click on it, you can customize it. Now, the reason I bring this up with simulation is because you have the ability to add simulation commands to the toolbar. And here's some of the fly-out simulation commands, or I could come in here and just select simulation. So in our case, for creating a new study, I want to put that on my toolbar. I can go ahead and place that in there, and now it will act just as any other command would on that parts shortcut toolbar. Notice it's available to me. Now I also want to point out that if I hit my S key, for those of you who have sat in some previous webinars, you know that it automatically activates my command search. Off to the top right, you see this box. Now I can also, if I hit my S key, let me just back out of there. If I hit my S key, it activates that, but I can also start to type in, and as long as simulation add-in is turned on, it will also sort through the simulation commands that are available. So really, all this stuff that we do on a regular basis, it's embedded directly in that. Now, one other thing I want to point out is mouse gestures. If I wanted to add a command to a mouse gesture, notice like simulation studies are in there, and let's just put some loads in here. You can see all my simulation commands are listed in here so that I can use mouse gestures to access those particular commands. If you don't know what mouse gestures are, you just hold down your right mouse button and drag it a little bit, and you can apply a command to a quadrant of this wheel. So the great thing about simulation and getting going is you can make it feel like you're already working, and I think that's important to do that. As with anything that we use in the SOLIDWORKS interface, most all the add-ins, there are options associated with this product as well. And if you go to the pull-down menu in simulation, you'll notice the simulation options about 3/4 of the way down. Notice there is no icon next to it, and if you've been using SOLIDWORKS for some time, you know that anything without an icon means there's no access to it from a toolbar. So I have to get access from the pull-down menu, and let's see if it's located over here. No, still not even over here on the right-click menu. So we have to go to this location to get access to it. And I'm not going to go in any detail at this point into the options. There's some very basic stuff that we can set here, but I just want you to be aware that those are available. So as far as the interface goes, I think you can pick that up very, very quickly. Let's talk a little bit about studies. We're dealing with SOLIDWORKS Premium, so we only have a limited type of study I can create. And in order to create a study, first of all, I can hit my S key now. I now have the command to create a new study. Or I can get from the consolidated pull-down menu. I have two options up here that have icons to them. I'm going to start with something we call the Study Advisor. Now, the Study Advisor helps you to understand and tie together what it is you're trying to get with the simulation. And it also ties in the type of study that you need to get that information. So it's a wizard-based tool where you basically make selections about what you're looking for, and it guides you through the setup of a problem. And I think this is a fantastic way to start learning the software. If you haven't used it previously, this is probably where I would start. So in this particular part, and I'm not really concerned about the load case, I just want to give an example here. So am I concerned about the deformation or the stress on this part? So I make the decision, yeah, I'm concerned about that. That's important to me. Well, how is that important to me? Well, is there a portion of my design that may only deform a certain distance? Maybe I have a certain clearance and I can only have a certain deformation. Or do I need to limit the deformation in particular areas of the software? Well, you know what? I want nothing in my design to deform beyond a certain amount. Now, as soon as you make decisions in this advisor, because it's kind of a guiding tool, it takes you to other things. And this is the first introduction of something that's in the base portion of SOLIDWORKS called sensors. Now, sensors is just a way of monitoring what you're doing in the interface and providing feedback. Well, in this particular case, because I'm dealing with simulation, it says, hey, do you want to look at the simulation data as a sensor type? Well, what information are we trying to capture? And notice it automatically says, oh, I'm looking for the displacement on the part. We can tell it how we want to measure displacement, and are we looking for the maximum value? Now, all I have to do is accept this. It's done all the work. It's set it all up for me. The only thing I'm going to add here is alert me if the stress is greater than, and you could put some value in here. So you can actually set an alert. Now, you can leave it off. This is just going to really report the information to you in the end. Once you've applied that, what happens is it shows up in a folder in your feature tree. Okay, there's a sensors folder, and we'll come back to that here in just a moment. Now, it continues on with this simulation advisor. It tells you sensors are convenient for tracking information, but are you also wanting to check for failure of the material? Okay, and it talks a little bit about stress and that information. Well, I don't know where to expect failure, so I'm going to go ahead and click on that, and it takes me right back to another sensor. It says, essentially, hey, if you want to check the maximum stress, well, why don't we report that stress to you in some way, and we'll use a sensor to do that. Notice it picked the same type, it picked stress, I can pick the units I want to report it in, and go ahead and accept it, and I now have two sensors. And I keep working my way through the advisor. And based upon the questions that I answered, it knows that I need to create a static study. So I can tell it create a static study, and it physically goes through and creates a static study. Now, how do I know I have a study? Because you probably didn't see a whole lot change in the interface. Well, first of all, on the bottom of your SOLIDWORKS interface, SOLIDWORKS is a bunch of years ago started implementing these tabs, one being the model tab where we design. We have the motion study tab for animation and the motion simulation product. And then I have two more tabs, which happen to be the two studies that I'm working with here. Okay. Now, it created this study for me so I can continue to move on. Now, when the tab is active, you'll notice that it will be bold to show you can clearly tell what the study is that you're working on. If you right-click on the tab, you can rename it, delete it, or duplicate it if you need to. Okay. Notice it also, in this case, applied gravity to the model. That's something we can add or remove, and I'll show a little bit more of that. So first thing to take from this, if you're picking up simulation for the first time, is look at the advisors. The advisor tools are all throughout the software, and they're there to help you make decisions about what you're trying to do. Okay, now I want to just go to the command manager here for a moment just to show you. There's a couple other advisor types. This one's called the fixtures advisor. There should be the loads advisor, the connections advisor, the results advisor. Using these is a fantastic way to get going on the software. Now, in my case, I'm going to go ahead and close this out because I want to take you through the journey of how do I work through setting up a study on my own. Okay. If I'm not going to use the advisor, I'm going to use the standard interface and the way of doing things. How do I go ahead and do that? Well, first of all, we go to the same option, create new study from the command manager, or I hit my S key and grab my new study from here. Now, if you have access to simulation currently, you may not have as many selections as I have currently. This is because what you see here for options is based upon what levels of simulation you have licenses for. You may only see static, which is our conversation today, which is linear static analysis. How do I make that assumption on parts or assemblies? I can provide a name automatically to this. I'll call this my test 1. And once I accept it, it creates that next tab at the bottom of the interface in SOLIDWORKS. Now you'll also notice the icon next to the test tab. That coincides with the type of study. I think more as you start to use it, you look at that and say, oh, that's static study, that's a static study, that's a static study. So you start to understand what the icons mean. Now, the way that I use the software, other than using the S key and the mouse gestures, I don't tend to go to the pull-down menus. I don't tend to use the command manager as much, and I think we've been taught that SOLIDWORKS provides shortcuts to get to a lot of things. Well, simulation is no different. Once the study's created, it splits the feature tree for you so that you can see the features in the top half, and the bottom half becomes the simulation tree. And you can drag this up and down, size it as you want. Now, what you're seeing at the bottom is the study itself, and then you're seeing 6 folders underneath it. Now, I call them folders because that's really the only way I can describe it. Each of these areas we're going to work through to actually set up a problem. The first one is where we set up the material. Now, this could have multiple components in it or a single component, and the symbol for it actually means something, and I'm going to talk more about that as we go through our assumptions and we talk about some other things. There's a folder for connections. How I describe that is how parts interact with each other. Are they bolted together? Are they welded together? Those are what we call connections. Fixtures is how we restrain the model so that it's realistic to its working environment. If it's bolted to something else, we might want to fix it so it can't move in certain areas. If it can slide, we might want to make it so it can slide. Okay, this is all done with fixtures. External loads are things like forces, pressures, gravity loads. Okay, and I would apply those through that folder. Mesh, I'm going to save for a little bit later conversation, but it's an essential piece to solving a simulation analysis. And then if there's a particular area I want to focus on, I would go to the results options. Okay? So these are all folders we're going to work through. Now, I said that we're going to learn a little bit different way to kind of interact with the tool. I kind of just go right down the folders and apply the information I need. Now, first one is the listing of the component or components that we're working on. And if I right-click on that, I have options specific to that component or components that I've right-clicked on. Now, some of them we're not going to get into right away, but the one you're really going to go in here most often for is the ability to apply the material to this. Now, I want to point out that the material in SOLIDWORKS was never specified. So I do need to specify it here in simulation. If I apply or edit a material, this should look very familiar to you because the interface for the material library in SOLIDWORKS is unified with the simulation material database. So as I go through and I'm looking for a particular material, I'm able to see the mechanical properties just as I did in SOLIDWORKS material database. These are one and the same at this point. But I do want to point out that if I've applied the material here, it does not apply it to SOLIDWORKS. If you go the other way and you apply it to the SOLIDWORKS material, it will automatically show up in here. Okay? So when I've actually completed a task or supplied information to simulation, you'll notice I get a nice little checkbox letting me know that I've done that, and I can kind of work my way down the tree. The next thing I think of in this particular study is, do I have any connections? Do I have any components that need to be bolted together? Are they welded together? Is there a spring connecting them? Is there a pin? And again, if I right-click on this connections, I get all the options related to specifying how parts interact with each other. In this case, we're dealing with a single part, so I don't have to apply anything. I want you to also notice that your advisor is right there on the top. So as I'm working my way down this tree, I could just grab that next folder and apply the information or get some advisement on it. Okay. Now, next thing we need to do is go to the folder for fixtures. Now, fixtures, I don't know if there's a great term for this folder, but realistically, we need to simulate the real-world environment where this part is going to be placed. Now, this particular part is attached to a bunch of other parts. There's pins in here. There's some bushings. On this end, there's a hydraulic cylinder that's applying some type of force. All of these things are going to play a role. Well, for our fixed geometry, for our restraints, I can right-click and I get a bunch of different options. What's great about this folder is no matter what I select in here, it takes me to the same dialog. So if I pick fixed geometry, it takes me to a property manager that shows me what fixed geometry is. I have a nice little image, but I can get to the other selections right here. So fixed, roller, hinge, if I click advanced, I can get to these other types as well. There's many different ways to apply these, and what you want to consider when you're in here is just making sure that you understand what you're applying. Does it really do that when you bolt this thing to the other components? Now, in this particular case, I have a pin going in the other end, so I actually want to simulate as if that pin was still there. And doing that with something called a fixed hinge, where it can rotate around the pin, because it's not welded to the pin. It can still rotate about that pin. So we're going to go ahead and apply that. Now, once we apply a fixture, it gives a generic name, kind of like a SOLIDWORKS feature. I can Windows slow click and call this my pin restraint. And I can give it something logical that makes sense to me, and I can continue to work and add other fixtures to this. So in this case, let's just add a few more. I'm going to use one called on flat face to make sure that these two faces cannot move normal to their surfaces. And now I've got all the restraints that I need in this particular problem that I'm setting up. But again, notice how the symbols for the fixtures represent the type of fixture that I've applied. Makes it very easy to understand what's been done. Now, if we follow our process of working our way down the tree, we right-click next on external loads. This is where I apply forces, torques, pressures, thermal loads. I can do all that from here. Okay, in this case, we're going to apply a force. And I can pick a surface to apply a force to. I can use the SOLIDWORKS model to do that. And I'm going to apply a force to these cylindrical surfaces on the end of the part, but the directions are off. So by default, it's set to normal. I can actually pick a selected direction, and when I pick a plane for a direction, it needs to know which direction along that plane am I actually applying the force, because it doesn't just assume the normal direction. If I pick normal to plane down here, you notice how it's now looking normal. I have a 30-degree plane. I can reverse direction. I can also switch units if I like in here as well. So let's put a 500-pound force on here. Okay. Now the other two directions are the X and Y of that plane. So if you're looking normal to the plane as if we were sketching, it's the X direction, it's the Y direction. Again, following what I'm going through, we're just dealing with the folders. Okay. Next thing we would do is work our way down to the next folder, then the next folder, and we would complete our problem using this method. I think it's probably the most efficient way of kind of working with simulation. But back to our conversation for a second here. We wanted to understand today how and when I can use SOLIDWORKS Premium to run an analysis. And in order to do that, you need to understand what makes a problem linear and static. So there's some assumptions about what we're doing that makes it linear and static. Let's go through those real quick. When a analysis is static in nature, its forces are applied slowly and gradually, but the real important piece is they never change direction. So notice just this example at the top here. If I apply a force normal to the top surface, as it bends, those forces stay normal to that top surface. Now, if something bends quite a distance, we know that that's not the case. Usually the loads reorient themselves normal to the surface. Well, if that's the case, then you can't use linear static analysis to solve it. Okay? So that's the first assumption. And again, in following these rules, 99% of the cases are going to be linear and static in nature. The other one has to do with the material. A linear material, when you look at how much force is applied and how much displacement results, it's a very linear curve. If I apply 5 pounds of force, I get 100 thousandths displacement. If I apply 10 pounds of force, I should get 200,000 displacement. So with linear static analysis, with Premium SOLIDWORKS, we're only supporting linear materials. Now, I'm going to kind of invoke some of my drawing tools here. What if I was dealing with plastics? And I had a stress strain curve that came up linear, and it kind of did one of this, and then it has its own, curve. Clearly not a linear curve. Well, can I use linear static analysis to solve a problem using that material? Well, the answer is yes, but only under a certain condition. As long as you're working in the linear range, and just pretend that that's a straight line, I guess. I don't draw very straight. But as long as you're working in this section of the stress strain curve, then we can go ahead and use linear static analysis to solve that. Okay, so that's the second assumption that we need to make here. Now the last assumption really has to do with how much it's going to displace. So how much deformation are you getting? If the displacements are small enough that you can ignore the changes in stiffness. So if I have a piece of steel plate and I'm bending it, and at some point along the displacement, that thing's going to become harder to bend. Its stiffness changes. If you can ignore those stiffness changes, then you can use linear static analysis. And again, in most load cases, most displacements, you can do that. So it's going to fall under this linear static assumption. Okay? So those are the three things we want to kind of focus on when thinking about what is linear static analysis. The next piece, and I kind of skipped over this with the folder, is what is a mesh? there's a folder called Mesh within the interface that is absolutely essential to getting results. Now, what a mesh is, it's a piece of geometry that gets mapped to your SOLIDWORKS model. And this geometry has a set of mathematical equations that can be solved to understand what it does. Now, this is what it looks like when you take one of our mesh types, which is a three-dimensional triangle, and you apply it to a model. Okay, so these smaller math pieces can be solved in one big problem by breaking it down into these much smaller pieces. Now, this you must know about SOLIDWORKS and when it comes to meshing. We don't just have one type of mesh. There's actually a three-dimensional triangle, a two-dimensional triangle, good for sheet metal parts. There's also beams and trusses. Now, the great thing about SOLIDWORKS simulation is it's going to help you to make that decision about what type to use automatically. So I want to show you a little bit of this using this model here. Now, I mentioned initially that the symbol next to the component means something. And it absolutely does, because the symbol represents the type of mesh that it's going to use. And it decides all on its own what it thinks the best mesh type is going to be. And if you're a new user, there's not a lot to think about here. You let the software figure it out. So in this case, that symbol is letting me know it's using a three-dimensional triangular mesh. However, if I right-click on the component, we were talking about some of the options. Here I can tell it to treat it as a beam. Well, there's no standard cross-section on this, so I wouldn't do that. But if I wanted it to be treated as a two-dimensional triangle, I could do that. Now, each of these mesh types has a place within the software. A best case on when and where to use them. For instance, beams are great for weldments. And anytime you create a weldment in SOLIDWORKS and you create a simulation study, it's going to apply a beam to all of the structural members. If you do sheet metal in SOLIDWORKS, that's best using a two-dimensional triangular element. And the software is automatically going to apply a shell mesh to that. So I guess, since we're early in this conversation for simulation, I guess the best thing to think about getting going is to just pay attention to the different icons that you have here. And I'm just going to treat this as a beam just so you can see. So if I treat it as a beam, I get a different icon. If I go back to treat it as solid. If I treat it as a shell, I can pick a surface here, and I just want to show you the symbol for a shell. Okay, the symbols actually give you some indication as to what we're dealing with here. Okay, and I'm just gonna. So now I'm back to treating it as a solid mesh. So now that we've made that determination, we've got some understanding about what a mesh is and how to understand where to go in the software for that. We need to understand a little bit more about our mesh folder. Our mesh folder is where I tell the software to break down the model into the pieces that I've determined up here, which is my three-dimensional triangle. Break that down for me. And just like all the other folders, I get to that through my right-click option. And there's all sorts of stuff in here. But what I'm looking for is to create the mesh. Notice there is an icon, so there is a command you could put in other areas of the software. Now, the first thing that the software always does is it looks at the characteristic lengths and thicknesses of the model itself, and it comes up with a size of the element to use. When I say element, that's the mesh, the individual pieces. Because it's going to put several of those pieces on her, what size is that going to be? Now, all it presents you with by default is this slider bar. Do I want it to be coarse or fine? And I can kind of just drag this around. If I click the box below it under mesh parameters, I can actually physically see what size that it's applying. If I hit reset, it comes up with the default and what it thinks is the best option. Now, let's go ahead and just accept the default here. And you'll notice that it goes ahead and it breaks down the geometry into these smaller pieces. Okay, each of them being a three-dimensional triangle that matches the geometry. And you'll notice that in this case, am I matching it perfectly in this corner? No, not really. But I don't really know a lot about what's going to happen here. So this may be good for me to get some idea about what's going to happen in my particular model. I could always come back here at any time, just like any other SOLIDWORKS feature. I could right-click on it, go back to Create Mesh, and I can actually drag the slider bar more to one direction and apply that, and it will actually refine the mesh on the entire model. And I can continue to do that until I find one that's adequate for my needs. And we can talk more about that maybe in another session of simulation. But that's what the mesh folder is for. Notice when mesh is applied that I actually change the symbol in simulation to show that it's applied, but also look at the material folder. It also changes the icon to let you know that you did mesh that particular part. You broke that part down into multiple pieces. Now, where that's a benefit is if I'm meshing an assembly of multiple components and one of them didn't mesh for some reason, maybe there's a model problem, that will not show up in this icon, so you can clearly identify which one did not solve. At this point, we have everything we need to kind of move forward. We're ready to go ahead and run. Now, again, there is a run that starts the solver in the software on the command manager, but as I've been showing today, just right-clicking on the right location in the tree will also get you started. I can go ahead and hit run in this case. Now, by hitting run, we're able to go ahead and look at the solution here, and it automatically provides me with some results. Okay. Now, I mentioned in the beginning a little bit about the options in simulation, and this is where I want to take you in just to understand a couple things. If I go back to simulation options, you'll notice that my results folder only has 3 things listed in it: stress, displacement, and strain. That's also coming from the default options. I say, okay, when I'm creating a static study, what do I want to plot out? Well, I want a plot of stress, I want a plot of displacement, I want a plot of strain. If I want more than that, I can add new ones by default. So I can tell the software what I want to be presented to me immediately after I'm done. Okay. When you get the software, get access to the software, poke around in here. Look at some of the things that you're capable of doing. Okay. So there's a little bit about the setup of a problem. I want to talk real quick about how do you get help? If you got access to this the first time, how do we kind of get going? Well, one great thing under the help menu, only when simulation is turned on, there is a set of tutorials specifically for SOLIDWORKS simulation. Even better than that is they've broken it down by the different packages. So if you just have access to our conversation today, linear static analysis, and you want to look at the types of things that you can do, go under static and you can see, everything from doing shells. We have some contact problems, remote load, shrink fits. These are all different phenomena that we can model up using linear static analysis. It goes into some beams, some trusses. There's probably 10 to 15 hours worth of tutorials to kind of get you going. Great place to start. It takes you through all areas of the software. Now, these are very much like the SOLIDWORKS tutorials. When you find a command that you're looking for, you click on it, it will actually hyperlink and take you directly to it. So that's a place to get started. Now, a couple other spots I want to point you to. Under the Simulation Help pull down, now we're used to going to the help here, but if you go to the Simulation Help pull down, there's a couple other things in here. There's a manual called the Theoretical Manual that takes you through some of the theory behind all of simulation. What is stress? What is strain? How do we apply certain things? That's a nice place to go. If your boss ever asks you, how do you know the software is accurate? There's a couple benchmark problems in here, so I can look at things that you can hand calc very easily and compare them in the software to actually running those benchmarks inside a simulation. They provided all of those as well. And then another one I want to point out, which I'm not connected to be able to do this right now, but if you go under the simulation pull down, there's a section called Research. Now, when I activate Research, it opens up on the task pane, and I can do a couple different things. First of all, I can get to the community. I can go ask questions of other people using the software. I can get access to the knowledge base. And now, if you've used the knowledge base, the SOLIDWORKS knowledge base on the customer portal, this is the same knowledge base. But I can put things in like applying a force, or what is von Mises stress, or how do I apply a connector, and I can get some information. If you have some material problems, maybe you don't have a material, there's automatically a search in here for MatWeb as well. Great place to go to get material information. So there's a lot within the interface to kind of get you going, get you started, learning and understanding what's there. Okay. Now, next thing I want to talk about, I know we're kind of running out of time, is a little bit about solving and viewing results, and I'll let those who want to stay to look at SimExpress stay. Once I've solved the problem, it creates also a folder within the interface. Now, that folder gives me those 3 plots that I talked about. If a plot is active, it will show up bold. To activate a plot, you just double click on it. So I can double click. Now I can also Windows slow click to change the name. But realistically, it's what we observe from the plots that helps us to make our decisions. So I'm a design engineer and I've just built this part. And I want to figure out, hey, what can I do with the size of this fillet, with the thickness of this rib here, and how is it going to affect my end result? Now, as a designer, you're just making assumptions. What if I could actually check that and see how it affected my results? Well, I do that by looking at my stress on the model and how it changes between different studies. So right now I have a baseline. If I have this radius and this thickness, I have 3.224 megapascals, very little load on this particular part. So how would I test another scenario? Well, very easy. I could go into SOLIDWORKS and I'm going to add a configuration. I'm just going to call this my new design. For my new design, I'm going to go make some model changes. Okay, I'm going to change this to 25 just for this configuration. We all know how to do this in SOLIDWORKS. And I'm going to change the fillet to 30 just for this configuration. So now I've made a design change. I have no idea if it's going to be better or for worse, but this will help me to validate that. You'll notice that as I did that, the previous study grayed out. Okay? Because I'm not in that configuration now. So what can I do? I can go ahead now and maybe create a new study. And let's go ahead and that should allow me to create a new study. Why is it not? Let's see here. Well, let's just activate that for a moment. All right, so if I create a new study, let's see. Why is that not giving me access? Well, I can create a new study on the new configuration, but let's go back to this just for a moment. If I take the static study that we had, I have an option to duplicate that study. And duplicating the study gives me the ability to say, which configuration do you want to use to duplicate that study? And I'll call this my test 2. Now, I want to apply the same information to the test 2 that I had on test 1. Now, in order to do that, I've got to grab the information that I've applied and move it over to that new study. Now, my restraints, my fixtures, everything here. Well, I can just go ahead and drag that from the tree, the grayed out tree, onto the tab at the bottom of the interface, and it copies that information over. So again, I can copy over the load. I can copy over my restraints. I can even copy over my materials that I've applied. And it brings everything along with it. So because the geometry changed, the only thing I have to do different is I have to create my mesh. Because I'm going to break down the model into smaller pieces, well, the model's changed, right? So I need to remesh the model. Now I can go ahead and run and solve. Okay. Now, with that, you can see I've got a higher stress value than I had before. I think it was 2. Well, let's look here. If we want to compare test 1 and test 2 and look at some results, I have a tool on my command manager called compare results. Now what this allows me to do is compare results from all studies, this study. You can choose what we're comparing. Okay, and what it's going to do is allow me to look at multiple plots related to the different study types that I'm working with. Okay, and I'm not sure why I'm getting this little blue bar. It might be my graphics card. But it's a great way of comparing my results, my von Mises stress in one to maybe my von Mises stress in another. This compare results is a great way of looking at that side by side. Now that I've injected simulation in my design process, I can make decisions. I can see clearly that with this configuration, my von Mises stress was 3.224. With this configuration, it was 3.114. Or 115. So we kind of started out this conversation today just understanding how simulation might fit into your process. And this is where I believe that it fits. As you're designing, if you could just make decisions, how thick should this be? How big should this hole be? Or, make design decisions and looking at the consequences. Now you can make decisions that maybe are a little bit more drastic. So for instance, maybe I've got enough that I could change this from 25 to 15 and really change the way our model looks, or minimize the amount of material, save ourselves some money in material. Now as a designer, unless you're hand calculating this, how do you make those decisions? This can be a tool that runs side by side to help you do that. To help you innovate a little bit more. Now I'm going to go ahead and kind of end the conversation at our introduction to linear static analysis. And if I go ahead and